Hi everyone, it's Emma and I'm back with another chemistry GCSE video. I'm a little bit out of breath. I've had a full lamb dinner and been up and down the stairs once. 8 months pregnant for you. Today I'm going to move on to a year 11 topic if you're doing WJEC. AQA and edexcel over in England, all of the topics you get in year 11, whereas in Wales you do half of them in year 10, half of them in year 11. Not necessarily the easier ones in year 10, but this one, bonding, that I'm moving on to, that is year 11 for WJEC, but it will cover all specs. This video does anyway. And today I'm going to look at something called Ionic bonding. So for the GCSE, you have to know about 3 different types of bonding. Bonding is just when atoms stick together. That is it. They stick together. And I'm going to show you why some of them stick together. And today we will look at ionic. So ions, remember? Ions, charged particles. So ionic bonding. All right. So this is the type of question they could ask you. I'm going to give you a bit of background. Basically, in an earlier video, year 10 for WJEC, I've spoken to you about all of the elements wanting a full outer shell. And what happens is they give or take electrons to get the full outer shell. And that was the beginning of the story, is that if they're in group 1, they've got 1 electron in their outer shell. They want to get rid of it. When they get rid of it, they become a +1, a positive ion by 1 because they got rid of 1 of their negative things. If they're in group 2, they'll become a +2 ion because they got rid of 2 negative things. If they're in group 7, they steal 1 electron, because if they're in group 7, they've got 7 electrons in their outer shell. They need 8 in total unless they are... anything group 7? No, it's only group 0, isn't it? And 1. So yeah, group 7, they all have 7 electrons in their outer shell. They all want to steal 1. So they become a -1 ion when they do this. But what actually happens is, groups 1 and 2, they'll give away these electrons. Groups 7 and 6 will take them. 1 becomes positive, 1 becomes negative, and they end up sticking together because of that opposite charge that both of the ions have. And that's the bond. Group 0 don't do this because group 0 all have full outer shells. All the rest of the elements are jealous of group 0. So today I'm looking at ionic bonding, and it's to do with the ions. 2 rules. The first rule is that they give or take electrons. So something gives and something takes electrons. Second rule is, what is the second rule? It happens, I've remembered it, sorry. It happens between a metal and a non-metal. So if you remember, the baddies go down to the police as your staircase. The B goes down to the PO. Look for oxygen, you know there's your non-metals. If it says to you, what type of bonding happens between carbon and oxygen, you look for carbon, that's a non-metal. You look for oxygen, non-metal. Well, it's not an ionic bond then, because it has to have a metal and a non-metal. If it says to you, what type of bonding happens between calcium, which a lot of people get confused by because they think of milk, but calcium is all the way over here, which means it's a metal, because the staircase, let me just put the staircase on this one. The baddies have gone down to the police. So everything on this side is a metal. So even though you think calcium's in milk, I'm not going to drink milk. Yeah, calcium in its pure form is a metal. If it said, what sort of bonding happens between calcium and oxygen? Well, calcium's metal, oxygen's non-metal. Therefore, that is an ionic bond because one is a metal and one is a non-metal. They like to ask questions where you've got to sort of draw pictures on these. So I'm going to show you one. For instance, this is an example, draw the bond that happens between sodium and chlorine. So sodium, Na, is in group 1, If it's in group 1, it's got 1 electron in its outer shell. Chlorine is in group 7. I can see over here it's in the non-metals because it's on the right side of the staircase. So that is an ionic bond that's happening here. And if they let you draw, like, put as much information on there. If it didn't tell you it's an ionic bond, write ionic bond on there. If it's worth 3 marks, you're not sure where these marks are coming from, put everything you know into that answer. They won't take marks away for you putting too much information on. The examiner is looking, they'll be there marking, looking for the bits they want to see. And it's got to go off the mark scheme. So, sodium, Na, is in group 1. Okay? Therefore, it has 1 electron in its outer shell. Now, you could draw all the shells, but for space, I'm not going to. This is the outer shell I'm doing now. Chlorine, Cl, is in group 7. So how many electrons has it got in outer shell? 7. What you've got to do is a dots and cross diagram. That's what's in the spec. I could have given Na, sodium, I could have given them the dots, and I could give chlorine the crosses, but I always just put the crosses on the first one I draw. So, this is an atom of sodium, this is an atom of chlorine with their outer shells. I've not drawn the other shells for space. Now, what happens is the chlorine is desperate for this extra electron. This sodium is desperate to get rid of an electron. So, they bump into each other. Sodium's like, do you want to take this off my hands? Chlorine's like, great, I want a full outer shell. And what happens is sodium donates, where have I put the spare? I just like my electrons to be in pairs, but you don't have to. Donates its spare electron to chlorine. And what actually happens then? Sodium then becomes a positive 1. By positive by 1, we don't write the 1 though. Chlorine becomes negative by 1. And what are they going to do? 2 opposites, they attract. So therefore, they will then become NaCl, sodium chloride. They will stick together. So there's the beginning of the drawing. It depends on the mark scheme as to whether you need to do another, you could draw another drawing where, I would say that would probably get you the mark really. You are showing where the electron started, where the electron ends up. You are showing the positive ion, you are showing the negative ion, and you are showing the new compound that's been made. The only other thing it might ask you is to draw, no, I don't think it's a different question that. So that is ionic bonding. Metal and non-metal give or take electrons. The metals give electrons because they're in groups 1, 2, 3. The non-metals take the electrons. I'll give you another example. Right, magnesium, Mg, it's in group 2. So try and take up less room. Magnesium is in group 2. I'm going to look at oxygen as well, is in group 6. So it's in group 2. It's got 2 electrons in its outer shell. So I'm going to draw it here. This is its outer shell. Magnesium, 2 electrons in its outer shell. Oxygen is in group 6. It's got 6 electrons in its outer shell. Always try to make this not look like a boob, but mine always do. Group 6. So I'm going to give this one dots because I already gave the magnesium crosses. Now, if you look at them, they both want full outer shells. Because they're not hydrogen and helium, they want 8 in their outer shell. Hydrogen and helium, because they only want to fill their first shell, only need 2 electrons. All the rest need 8. So this magnesium bumps into this oxygen. And the magnesium's like, I want to get rid of these 2 electrons. Do you want to take them? Oxygen's like, great, I'm in group 6. I need another 2 electrons. I'm going to steal them from you. So magnesium then gives away 2 of its negative things and becomes an Mg2+. Oxygen steals 2, so it becomes O2-. Now it's an ion. We don't call it oxygen anymore, we call it oxide. If you look on the back of the periodic table, like I said, there's an ions table that will guide you with this. And it will have magnesium Mg2+, and have oxide O2-. The only thing I haven't done yet is I haven't shown the 2 electrons moving over. Now, the questions are different every year. This is the outline of it. So
if it said, show the bonds that happens between magnesium and oxygen, I would draw all of this, draw what they started off, draw their chemical symbols, draw their outer shells. You could draw every shell. If you're not sure, just say, oh, I want to draw all the shells, that's fine. I'm just doing the outer shells. And what would the chemical formula for this be? Well, we've only needed one magnesium and one oxygen. So the chemical formula for this MgO is just like that, because you only need one of each. I'm going to show you one more where they're not equal, and then that will be it for this. So I would say this video is for foundation and higher. It would be a harder question on a foundation paper. Maybe you just needed to fill in a gap somewhere, and higher you might need, you will need all of the information. So let's go for lithium. I don't want to do them too big. Lithium oxide. Lithium oxide. So Li. So show the bond that forms lithium oxide. So you've got lithium, you've got oxygen. Lithium's in group 1. So it's got 1 electron in its outer shell. I've used the cross there. Oxygen's in group 6. It's got 6 electrons in its outer shell. Hopefully I'm not doing it that small that you can't see. Okay, so this lithium bumps into this oxygen. It's like, I really want to get rid of this electron. Oxygen's like, brilliant, but I need 2. So what oxygen has to do, it's got to bump into 2 lithiums. So another lithium comes along. Now you could put it in a bracket and put ×2, but I'm more of a visual person. So the 2 lithiums now both have 1 spare electron each. Oxygen is desperate for 2. So this lithium will donate its spare electron, and this lithium will donate its spare electron. Okay, so both of the lithiums ×2, they will become a plus, because we don't write the 1. Although if you wrote the 1, I don't think they would mark you down at all for that. So 2 lithiums, they become a lithium plus, and then oxide, there's only 1 O2 minus. Now this is where we've got to look at what would the chemical symbol be for this. We've got 2 lithiums. So Li, you can't put a 2 at the beginning. If you put a 2 at the beginning, it means you've got 2 of everything in there. So LiO. No, you cannot put the 2 there. You've got 2 lithiums, so put your Li and then you put small 2. Oxygen is only 1, or oxide. So I don't think they would mark you down for writing the 1. It's just we don't write 1. Just like I wouldn't put 1 there, because the fact that I've written Li shows that there's 1 there. So they are the more complicated questions where they're not an equal number. Okay? I've just said okay. I'm sure I've done well in this video. Not saying okay, but never mind. So that is the first video I'm doing on ionic bonding. I'm probably going to go through the first topic for year 11 on bonding, smart materials and things, and then I'll come back to do higher and triple stuff. And it's not that this specification is different, it's just I'll show more complicated questions. Okay? I just said okay again. Thanks for watching. I'll see you soon.